All right, good afternoon, folks. Before we get started, I want to point out a couple of things. On Blackboard, for today's lecture, I do have a Tilemap lecture repo that has some of this stuff set up already. I'll talk about how you sort of import some of the things and make some changes, but for the most part, the sort of setup along with the little Tilemap graphics things that I have a few are already in there. Otherwise, you have to like import some packages and a few other things like that. So I'll talk about how that's done, and some of it's in the slides for today, but it'll already be sort of mostly imported and mostly set up. There's also two scenes. One of them is the finished scene, which might actually be loaded first. I'll have to check. And then the other one is sort of a starter scene that just has sort of the camera working and an empty player game object. So stuff that we'll just add to. So it's worth going on and grabbing this. It should be public, so you should just be able to go in and then take it. And then of course it takes a few minutes to open once you get to that point. The other thing that we'll talk about here in just a moment, probably close to the end, is the final project stuff. So I'll mention that a little bit later on, I think. Before we do Tilemap stuff, I wanted to just go back into Spectre for a moment. This isn't something that you necessarily have to do, but I wanted to show you how to put in a fixed update into your state machine. So remember, we have two different updates that we typically use. There's update and there's fixed update. We haven't really followed this rule for our projects, but in general, you should get input information. So, whether a person's pressing a key or whatever sort of joystick input, whatever it might be, you should get that in the update call. And you should do any movement, so anything related to a rigid body specifically, you should do that in the fixed update. Fixed update is based on the physics tick. So when Unity goes through and does all of its normal physics stuff, that happens on the fixed update. So it's possible to get multiple update calls in between physics calls, because physics calls might happen less often. They might be 60 times a second, whereas based on the frame rate of your game, your update might be being called hundreds of times, potentially getting sort of hundreds of FPS. So it's possible you get more update than fixed update. But anything that interacts with the physics engine should be done in fixed update. So moving rigid bodies is using the physics system. So it should be in fixed update only. Now, you may not notice anything by having everything in update. You certainly shouldn't have everything in fixed update, because that runs at a slower speed typically. So you might not notice any difference by making some of these changes, but it's generally good practice to use fixed update for any physics things and regular update for gathering the input, seeing if someone has pressed a key. So I currently have our Spectre open, and it's just a little bit of changes to some of the code. So in our scripts, and you don't necessarily have to make this particular change. You don't have to have this open and making the change with me, but I just want you to see sort of the basic way to do this. So right now, if I open up the, let's open up the game manager. If I open up the game manager, everything is happening in process for our game. So all the movement stuff is happening because in process, when we are in the sort of normal update state, we're calling entity action. So all of this is happening in update effectively, the way that we've set up our state machine. So we want to break that out in that we want to have another function here that does all of the fixed update stuff. So I'm going to make a quick public void, and I'm going to call this fixed entity action. And we can put whatever we want to in here that needs to happen in the fixed update. It's likely going to have a similar sort of for each loop here. But we're going to have to put other calls into here, the stuff that would happen in the fixed update, which is the actual movement, the actual rigid body movement. Whereas in regular entity action, this will be where we actually get the movement. So in other words, what keys are being pressed, how our analog stick is pointed, that sort of thing. So this is something that we're definitely going to need. We're definitely going to need to add that in and put the appropriate code in here. For our state machine, we need to add essentially another function call that we can do in our current state. So right now, the only thing that state ever calls is process. We don't have anything else in here related to what the state calls. So in my state machine, in the abstract class, so our base state class, I'm going to add another function in here, and it doesn't really matter where you put it. I'll put it underneath process. And all it's going to do is going to be public, and it's going to be void. It's not going to return anything. It's just going to be a fixed update, kind of like our update, but this is meant for fixed update. And we can make it virtual, so we can override it. We could also make it abstract because it doesn't really make any sense to have it in this base class to have an implementation. So if you make it abstract, that's fine as well. We are going to override it in our base classes. But I want you to think about this. If we have a fixed update now that we can call from that we can call as part of our state machine, then in our game manager, we can have a fixed update, and we can call state.fixedUpdate. So this fixed update call is the thing that's running on the physics timer. Update is running on however fast we can process our frames. So now we have another function that is only going to get called on the physics updates, and that's this one in our state machine. So in each individual state, we can override it. So we'll override fixed update. And in here, I can call game manager dot fixed entity action. And I think that's all the changes we need to make, actually. So think of this update as being called every frame. And this update, let's say something like must be called in fixed update in the game manager. So now any of these, any place we need a fixed update to be run, we can just call this function as part of our state. And remember, our states, let's see. We need to have, I don't think I put this in here. I think I must have missed that when we did it a while back. This should be state equals state.process. This one doesn't have a return value. So whatever state currently is, it's going to run whatever fixed update is associated with that. For our game over state or something, it doesn't really matter. We don't need to run anything necessarily in fixed update. But if we had different states that needed to run different things during fixed update, then we could throw that into our state machine. So it seems like a roundabout way, but it gives us a little bit more flexibility. So we call fixed update on the actual fixed update, which eventually calls fixed entity action. Now we need to hook in our entities. So let's think about the player first. So we got player.move. If we open up the player script and we look at move, it's doing both things. It's getting the movement, which is getting the input, and it's doing the movement for the actual calculation of the movement with the rigid body itself. I don't want to do that. I don't want to have this function do both. I want to split it up. So we have get movement, that gets the input, and we have, I remove get movement here, and we have move, which does the rigid body. So I have them separated into two separate functions. Now if I go back to my game manager, in the entity action, I should do get movement. This only gets the movement, the keys that are pressed. And in here, I should do, and I'm going to have it outside the loop because there's only one player. I'm going to say player.move. So now the move happens on the fixed update. The getting the movement happens on the regular update. And we have to do the same thing for enemy. So the benefit here of having a sort of hierarchy like this is I don't have to change much. We did it sort of the same way for the enemies as well. I can remove my get movement here. So now move only does the rigid body movement, and get movement is overridden later on. Is overridden in our specific classes. So in Game Manager, I do get movement. And in here, I can do e dot move. So the movement will actually happen on fixed update, and the get movement should happen on here. And I think not accessible, so that's something that you might have to change. This one shows as good there. Let's check the individual guys here. Yeah, they seem to all be okay. Should be accessible. Yeah, I spelled it wrong or something. So yeah, so there's our get movement. Here's our move. So our moving, our actual rigid body motion is happening on fixed update. Getting the movement is happening on regular update. Let's see, and sort of assuming I haven't broken a bunch of stuff, we should still be able to move just fine. But now it'll be in my mouse needs to be over here. So our movement is just fine. Everything sort of it actually, if you do this, it actually sort of feels a little smoother as well, because you're not updating the rigid body every potentially hundreds of times a second. Different from when the actual physics updates are supposed to take place. So it can actually feel a little bit smoother doing this as well. So that's something to keep in mind. Ultimately, when you're making a game, whatever feels best or looks best is usually what you want to go with. But sort of the standard practice in Unity is to make sure that physics things happen on fixed update, input things happen on update, and of course, whatever other stuff, graphics things and sound things, they usually happen on update as well, because you want them to happen immediately, not to wait for the next physics update. There are usually some questions about whether or not you lose input potentially. If for some reason if the physics engine, for example, is updating faster than the regular sort of frame updates to regular update, it is possible to lose input if you get the input in fixed update. So there are sort of things you got to pay attention to depending on how you set this up. But for the most part, this is the way that you should be going about it. So it's just a couple of code changes. The biggest thing, of course, was in our state machine adding a fixed update. So starting with just an empty one, or again, you can make this abstract if you want to, and then overriding it where it calls the fixed entity action from our game manager. And then it's just a matter of taking whatever needs to be split up, the move compared to get movement. So you don't necessarily have to do this, but it is something to think about when you're working on games in the future. For the most part, we sort of ignored it for our games, and we didn't really have too much of an issue. If the game's fine and you do it one specific way and the game's fine and everything feels good, then then it works and you can leave it that way. But sometimes there are issues or sort of weird sort of stuttering things that you might see every once in a while that tends to happen if you don't do it this way. Okay, so is there any sort of quick questions on that? I just want to do this. I just wanted to sort of do it real quick to sort of show it. Is there any sort of quick questions related to that? Okay, so we're gonna go do the Tilemap stuff, and Tilemaps are super useful. Yeah, this save, and I'm gonna start opening the other one. So I have one called Tilemap Lecture, and we'll sort of go through it here in a second once it opens. Tilemaps are super useful. So any game that uses a sort of grid of tiles, you can sort of consider that a tile map based game. The image I have here is from Terraria, but I mean, I imagine you could think of tons of different tile based games. Tiles aren't always square either. You can have sort of mostly any shape of tiles. Sometimes you need multiple shapes to fit a grid together, depending on the shapes you use. But you can imagine things, squares, triangles, hexagons, that sort of stuff. Sometimes it's obvious that a game uses some sort of tile set. Sometimes it's not. It depends on what style the programmers are going for. Typically, the collection of tiles that's used to create a game is called a tile set. Usually, it's just a single image in a sprite sheet. So you have some gigantic image with a whole bunch of tiles. Sometimes you have multiple files. For example, this is like a snow biome. So my guess is sort of internal to their game, they have a snow biome tile set, and it's an image that has all their snow biome tiles that they use. I said Terraria is relatively well known, but I'm sure you can probably think of lots of other games that use a tile-based system. Tiles don't just have to be 2D either. You could have a tile-based system where you put 3D objects on top of tiles. If you think of something like the Civilization series, after they went 3D, you can sort of imagine something like that as well. So it doesn't just have to be 2D tiles looking from a side on or a top down or something. You can have 3D objects there as well. So I created a sort of starter scene for you, and it has a Cinemachine camera and a few things set on the Cinemachine camera and stuff. So it's not a completely blank scene. I'm going to sort of walk you through some of the changes that I made to some of the stuff already. So making sure that things like the Sprite 2D package is loaded and the Tilemap package is loaded. There's actually an extra package in this one called Tilemap Extra, which is something you actually have to download from GitHub. It is an official Unity thing. It's just not part of the package manager, at least in the 19 version of stuff. The point here is that we start by creating a palette. So we start by saying, these are the tiles that I want to put in my scene. So we're going to look at a couple things in the scene, and then we're going to make this palette. And I know it generally takes a few minutes to load stuff up. So I'll make sure that I'm not sort of going through all of the bunch of new stuff before folks have things loaded. So what I have right now is I just have in my scene here, I just have the 2D camera, so I can put the grid on here. I just have a 2D sort of setup here. If you have the finished one loaded, so let me load that scene and unload the starter one. It has essentially what we're gonna be making, at least part of this today. So I created this tile set, so it's a relatively crappy tile set, but you can go out and find lots of other tile sets out there. It has a little bit of lighting and all kinds of other stuff. So you don't need to have this one loaded. So on the scenes up here, if you right click, you can, well, you have to have another scene loaded. So I'm going to load up the starter scene and unload my finished scene. The scenes are also in the scenes folder. So if you don't see the starter scene, it should be down here. You can double click on it and load it up. So the only thing in here is a main camera and a Cinemachine. The main camera itself is not sort of a whole lot is different here, other than it has this pixel perfect camera, and we're going to talk about that a little bit later. For now, I'm going to turn that off. We're going to notice some weirdness with our tiles with it off, but this is something that I do want you to be aware of. That when you turn this on, typically for tile-based type games, you want to have this pixel perfect camera thing on. So that's just a component. Pixel perfect camera. There's two versions here. I have the experimental one on. There was probably an update or something where they made it non-experimental. Again, Unity changes at such a fast rate that sometimes stuff is experimental, and the next version you use, it's not. So I have the experimental one here. It tends to work just fine. So you can mess around with this in other projects and add the sort of non-experimental one in if you want to. But for now, I'm going to have this off, and we're going to see some weirdness. There's an empty player script. It actually has a circle collider. I'll remove that. Actually, we'll add that back in later. So I have basically an empty player object. We're gonna add a script to it and add a rigid body and all that kind of stuff a little bit later. As far as the folders here go, I have an empty palettes folder. I have the scenes. I have no scripts. There's some settings based on using URP, and I do have a sprite sheet. This should already be set up just fine. So it's a sprite sheet, multiple sprites, 16 pixels per unit. If I look in the sprite editor, it's the actual tiles themselves. So in a painting program or whatever, you can make whatever tiles you need. You oftentimes need a lot of different types of tiles to represent things. So this will make a specific room. If I zoom in a little bit, what you can see is this is sort of our sidewall. So think of sort of a top-down view, kind of. We have our top wall. We have the corners here. We have the bottom wall. And then I have something that kind of looks like this sort of sidewall again. But notice it has it's slightly different. So it sort of goes next to this wall here, and then we have the wall. So it's kind of at an angle, but not really. The floor is a center thing here. So you can sort of think of this as a room, a way to make square rooms. If you want to make other styles of things, you need more tiles. So oftentimes, just to make a sort of basic and sort of a dungeon style tile map, in order just to make basic rooms, you need on the order of dozens of tiles to make sure that you can make any sort of shape of room. And then there's a couple of like placeable things here. So there's a dumb little chest and something that kind of looks like a vase, but was meant to look like a barrel when I was originally drawing it. So I know there are definitely folks in this class that can do pixel art better than I can for sure, and can probably come up with a much better looking example tile set. But this is something that was custom drawn. I didn't download this from anywhere. And I don't remember what the size of it is. I think these are 16 by 16, which is why it's 16 pixels per unit. So remember, a unit in Unity is one of the sort of Unity squares. It's one of the squares in this sort of grid here, if you look at the grid in the scene mode. So it's 16 pixels should fill one of those squares. So we'll have sort of a relatively pixelated game if we were to make something with this. So that's a tile set that you get. They've already been set up. So the tiles are sort of already broken up. The filter mode is a point filter, so I don't get any sort of extra blurring or anything because I want it to look in the sort of pixel aesthetic. So the first thing that we do if we want to make a sort of tile-based game and use the tile editor and stuff is we make sure that we go to the package manager. So that's a window package manager. And we make sure that that everything loads up here. And there's two things that we want. Type in 2D. There's two things we want. We want the Tilemap editor, and you're typically going to want the 2D sprite package as well. So these you need. The Pixel Perfect package here is the one that gives me the Pixel Perfect camera option. So you likely will need this one as well, but it's not required. To use the Tilemap editor, you don't have to have the Pixel Perfect thing. It just will make stuff look better, as you'll see in a moment. So, but you need the Tilemap editor and you need the 2D sprite. There's a few others potentially that you could get as well that are related to 2D stuff if you have the need for that. Like if you're doing everything in Photoshop, you probably want the 2D PSD importer, for example. So there's some other options there, but you need the sprite and you need the Tilemap editor piece. Once you have the Tilemap editor and the 2D sprite stuff installed, if you go to Window and you say 2D, you have an option here for a tile palette. Let me turn on, I didn't turn this on last time. Let me turn on the pen attention thing. Okay, so under Window 2D, you should have the tile palette. And if I open this up, this is my tile palette from the finished version. So we don't want to use this one. We want to create our own. So there's a drop down next to this edit button, and it lets us create a new palette. So we're going to create a new palette, and we're going to sort of import stuff in. It's the same process to get you to this point, but I want to sort of do it ourselves. So I'm going to say create new palette, and I'll give it a name, and I'm just going to name this I don't know, my palette. And the grid's rectangular. There's a few options here. There's a hexagon, an isometric, and then a sort of a rotated isometric. So there is options for other shapes that you can use. Isometric is particularly nice for things that have that sort of 3/4 view. And hexagon is nice for certain types of games as well. The grid size is just going to be automatic. You can manually set this. It's typically automatic is going to work just fine. So I'm going to say create, and it's going to have me save it. So the first thing it wants me to do is save it. And it's just going to be it just wants the folder. So typically for the palette, I have a palettes folder. So right now it's empty. That's the one I'm going to use. They just say select folder. So now I have an empty palette. And in my palettes folder, you can see the palette here. And you can create as many palettes as you want. You could have one palette for outdoors, one palette for indoors, and one palette for like have your placeables, right? Chests and keys and stuff that's laying on the ground. And you could have another palette for I don't know the player, for instance. Maybe the player can have different sprites in certain situations. So you can create as many palettes as you want. There's not really a limit on that. To get tiles into the palette, you might be able to barely read this. It says drag tile, sprite, or sprite texture assets here. So we can open up my sprites folder, and I can just drag my sprite in here. Now, it also saves the sprites as tiles. So I already have a sprite saved in Unity that represents this tile map, but Unity also saves the individual tiles that are part of a palette. So if I go back to my assets, the typical thing that I do is I go into the palettes folder and I create a new folder in here. And I just give it the same name as my palette. So this was, I think it was my palette. So I create that folder and I select a folder. And I'll show you what this looks like. And it takes in all of my individual sprites in there and it shoves them in here. They're not arranged in a useful way, but that's the way that it loaded them in. So in my palettes folder, I've got my palette, which is the actual palette itself, and then I have all of the individual sprites that make up that palette. The reason why you might want this is because we can actually create rules. We can create what's known as a rule tile. And so we can have a tile inside of here that's called a rule tile, and then we can actually just paint, and the tiles will automatically change based on what's next to them. That's something we'll talk about next time. But for now, just know that these are the tiles that are part of this palette. Now, a lot of times I harp on organization, and this is one of those times. I want this to look like an actual room. So when I'm painting tiles in just a second, it'll actually make sense which tiles I'm grabbing, because I don't really remember, like, what is this tile? What is that tile supposed to do? Which side does it go on? Does it go on the right side, left side? How does this work? So I'm going to move these around. And yeah, we have a little sort of warning here because we don't actually have a tile map in our scene yet. So we're going to make that here in a second. This can be a little bit clunky, and this is one of the sort of these situations where Unity is still working on this stuff and changing these things. So, 2 versions down the line, 2021 version, this might be very different. So it's one of these challenges of being part of one of these sort of big software, big sort of game engine companies, that they change stuff quite often. So it's a little bit clunky. You basically have to select the tile, and so there's a few options here. So there's the arrow, which lets you select tiles, and there's this movement thing, which should let you move tiles, although it can be a bit of a pain to make sure that it's working. There's some other tools here for flood filling and erasing things. So let me do that. I'm going to grab it with the brush, and I should be able to. Yes, we need to do. Now this is one of their other little things. We need to click the edit button, so it's highlighted, and now you can see that I have that tile in sort of my hand. So I select the tile, and then I can move it around in my palette. So the edit does need to be on for that. That's something that I typically do forget, and then we can move them around. So I want to layer this out so that it kind of looks like a room, essentially. So I know that the sort of full brick tile is right above, and to scroll, to move around, to pan in this, you just hold down the middle mouse button. So I know the full brick wall is right above my my roof, or my room here. I think this one is the one that goes here. And this one, you constantly got to switch back and forth, and there are hotkeys for these as well. Here, I think this one's the one up here. So I'm just rearranging them. This can be a bit of a pain, which kind of sucks. That's what the rule tile's for. The rule tile makes it so you don't have to worry about this. And then I have my 2 little edge corner pieces here. And I'm going to move this barrel and the chest around as well. So the point is, you can rearrange what these tiles look like. So this is my sort of standard square room tile, and then I have a couple of the placeables. After that, I want to unclick on edit. So now it's sort of saved in this configuration. So that's my palette, my sort of dungeon palette, or sort of whatever you want to call it. I might have dozens of tiles in here. I might have stuff that I can make a bunch of different shapes of rooms. I might have like circular rooms as well, or tiles that could represent circular rooms, and there can be all kinds of different stuff that I do in here. So I just wanted to give you a very basic room here that we're going to paint in a second. So with the sort of palette set up, now we create a tile map, something that we can paint these tiles onto. So let me jump back to the slides here. So here's a few of these things. Create new palettes. Arrange the palettes in here. I mentioned that I typically put the tiles that it creates into a folder within the palettes folder. So how I sort of do my organization. Again, you can make as many palettes as you want. You can switch between them just with that drop down. So I had that dungeon one from the sort of finished product. Now I have this my palettes one, and you can create as many as you want to help with organization. Let's before we actually make the tile stuff, let's make a little player. And this player's not going to move along the tiles. The player's going to be free to move however they want to. So again, think about a game like the Binding of Isaac, for instance. Right, so that is that's pretty clearly a tile style game. You have a bunch of tiles, and there's things that you place like rocks and jars of stuff, and items that drop on the ground and things. But you're free to move sort of anywhere within it. So we're going to do something similar to that. So we're going to take this player movement script, very simple. It just has a start, update, and a fixed update. The graphic that I'm going to use for this is just one of the UI graphics probably. So I'll show you what that looks like in just a second. So let's do that real quick. Let's make this little script. So I'm going to close the tile palette. If I want to get that back, I do have to go Window 2D tile palette. So I do have to do that to get this to come back up. Script-wise, I'm going to create a new C# script, and I'm going to name it. You shouldn't name it movement. You should just name it move. The reason why is because in finished here, there's already a movement script. So don't name it movement, otherwise you'll have two scripts in the project name movement. So name it something different. So I'm just going to name it move. I'm going to open it up. And we'll do some very basic movement here. There's just going to be a couple of variables. I'm going to have a private vector3. You can probably have vector2 if you want as well. Move amount. And we'll have a private rigid body 2D. So call that RB. And we'll have a serialized field. I don't know if my autocomplete stuff here is going to come up. A serialized field. And this will be a private float speed. I think is what we had. This is probably. Okay, so just a couple of things. This is our vector we're going to move along. This is a rigid body, so we do need a rigid body on the player, and that's our speed. Start, we're just going to say the move amount is just a vector 3.0. And we'll do weirdness here. We'll do the RB. RB dot get to components, and we're going to grab the rigid body 2D. So just to make sure we have it, so standard stuff here. In update, every single time through update, we're going to change the move amount to be a vector 3.0. So we're going to sort of zero it out. We're not going to have any sort of acceleration or anything like that. And we're going to grab the input stuff. So we're just going to grab a float, and I'm going to call this V input for vertical input. And this is going to be input get access raw, so similar to stuff that we've done in the past. And this will be the vertical axis. And we'll do the same thing, but for horizontal. So again, this is all in the slides, so there's nothing sort of crazy going on here. And we've done some stuff similar to this before in Spectre as well. So we got horizontal. Yeah, it's giving me some weirdness here. It's got to be a VS Code thing. So the move amount. Move amount is just a new vector 3. It takes the H input and the V input. and 0 for the z. And then I'm going to normalize it. I think this is a function call, so it should be a copy, if I remember correctly. I'm actually going to save this and close it and remake the stuff, see if I can get that to go away here. I'm going to rebuild the project files and open it again. So relatively simple stuff that should make sense. Start the vector at 0, grab the horizontal and vertical input, throw it into a new vector, and then normalize that vector. So that's just getting the movement. And then, of course, because we're going to have a rigid body, we have a fixed update. Let me actually use the snippet thing here. We have fixed update where we actually move the rigid body. So that can just be rb dot velocity equals move amounts times speed. And this should work fine. We could use some of the other rigid body calls, like there's the move amount. I think it's called move amount call or those. But we could add other, we could do say like add velocity or something. But this should be fine. We're just directly setting the rigid body's velocity to be the basically movement that we do, and we do that every single physics frame. So I just wanted something simple so that we can have a little object that moves around, because we're going to be adding some collisions to these tiles. Because if we're in a room, we don't want to be able to leave the room. So that's why I'm sort of writing a little bit of code here for some movement. And again, it's the sort of stuff here is on the slides. So back in Unity, make sure this actually compiles here. Oh, did I may have messed. Should work. Let's do a different one here. Let's see if that's. This may have been from the previous version where this was accessible as well, which is always nice. Okay, so you're gonna give me stuff here. Make sure it's all looking right. So see about this one, and we're gonna do times speed. Might have to use that one here. Nope. Let me grab one of the ones from. Yeah, it should be add velocity. Should be fine. Because it's sort of the regular one that we've done before. We can always try. Why this would be an issue here. Let's do. Let's see. I guess let's try what we did for the other one. I don't know why I'm not getting the stuff here. I wonder if was it add. I just missed the capital on it too. Maybe. Let's try the add velocity here. it's not giving an error here. I'll do it here. So let's try the move position one. Otherwise, something's definitely up with my VS Code not giving me all the correct stuff here. Let's try move position. That might be it. That is likely, that potentially could be the problem there. Okay, let me try the RB. I think it's capital move position. Remember right? RB that position. Move mount. Speed times time dot fixed. This still gives me some issues then. Yes, potentially, Nathan. Yeah, potentially we could do we could try the add force as well, because we messed around with that. I forget which one it was, because then you do the force mode, like you can do like impulse too, and it should give something interesting as well. But I don't know why it's not. 2, 3. This was vector 3. So these must be vector 2s for these. Yeah, I don't know what was up with the add velocity, because that should have worked just fine. So let me try that. We're gonna add the script to here, and we're gonna add a few things. We're gonna add the rigid body, and then I'll go back to the code real quick. We'll add a rigid body. This, we don't want gravity on here, so we'll do that. And I'm gonna add a circle collider. And we need to add a sprite renderer. So just adding a few pieces. We need the rigid body. We know that. We're going to need a collider. We should know that as well. The sprite renderer, I'm just going to pick one of the default sprites. I'm going to pick this knob sprite, so it's just going to be a little circle. And I want to change the material. Right now it's a lit material. I'm going to change that to be a sprite unlit default. That way it doesn't have to worry about lighting or any of that. So my player, let's see where this guy is. I'm going to zero the player out here and go to the game view, and we should have a little circle here. If I kept the sprite unlit default, it would show up as black, because I don't have my light here. I think is not very intense. The intensity is only 1 on it, so I'd have to increase the intensity and make sure it was all the correct direction and stuff. So for now, I'm just going to use the unlit. Use the sprite unlit default shader. So this should let us move around. Let's make sure this is actually going to work here. No, it's giving me some problems. Let's see. Update. One more thing. Our speed needs to be some value. So I'll change the speed to 5, and should go. There we go. Now it's going to look like it's sort of doing this little bouncing thing. That's because of the camera. So I'll show you that here in a second. So let me go back here. Again, the add velocity should have worked. I don't know if I have something that's changed since I messed around with Tilemap stuff before. So the move position should work, but Nathan, your one by adding a force should work as well. It should work fine. So just make sure if you do move position, you have the current position plus whatever the vector is times the speed. So you sort of take that vector that's just the direction at this point because it's just normalized, and it expands it by the speed, and then we multiply by time.fixed delta time. You can actually use time.delta time in here, and it'll work just fine as well. Unity's smart enough to know that if you're in fixed update and you use time.delta time, that it will use the fixed delta time version. So Unity is smart enough to know that. But if you want to be explicit, you can use fixed delta time as well in here. So again, update is just getting that vector, that direction vector. The fixed update is just actually moving this as well. So stop here. The reason you know that this is actually working and that it's just the camera that's doing this, if we look at the scene here, and let me pull this to the side here. If we look at the scene, you can see that the camera is just moving along with us. So it's just based on the camera that I have settings. So it's going to look like on your screen, on your game screen, it's going to look like it's not moving, but it actually is. It's just because the camera's following it within a certain box. If I click on the VCam, there's the box that it's following us. And it moves sort of slightly to get us back in view. So it is actually moving. Everything is moving just fine. The camera's doing what its follow thing is supposed to be. It's just having a solid color background means that it's a little bit difficult to tell how we are actually moving. And those settings should already be set. For the player, or for the camera, make sure that the follow and the look at are both set to the player itself, if that's not already done. So on your Cinemachine camera, make sure that those are set, which I think they should be already, but if they weren't for some reason, make sure that those are set there. Okay, so let's get back into the sort of more interesting stuff. So I think on the slides. All right, so we're going to create a tile map. Yes, Nick, back here. There we go. So updates, just grabbing the axes, normalizing that vector, and then the fixed updates, just doing the move position. Which, again, the add velocity should work just fine. But I wasn't getting the autocomplete either, so I don't know what's going on. And make sure you set speed to a value. Yeah, so in here, yeah, so I had to go back and change, because we're using rigid body 2D, RB.position is only a vector 2, so I had to go back and make sure that my move amount was only a vector 2 in those places. And up here at the top. All right, so let's actually make a tile map. So in my hierarchy, I'm going to right click, and I'm going to go down to 2D object, and I'm going to say tile map. Again, this isn't going to show up if you don't have the 2D tile map package and stuff installed. And there's a few other ones in here. There's hexagonal point top tile map, hexagonal flat top tile map. So there are multiple orientations that you can have a hexagonal tile map. So you can have it be flat on the top and arrange them that way. You can have it be a point on the top. So they have options for that. They have options for the two isometric versions as well. So if you have isometric tiles, you have you want it to be isometric. You can sort of you can, if you make one of these, you can adjust like the skew and stuff. So basically how isometric they are. You can do that as well for depends on whatever your graphics look like. So we're just going to take a straight up tile map. That is a square tile map. Now it creates this grid object for you and then puts a tile map in underneath. So the grid itself gives you some options about, all right, what is a cell layout? Here's the hexagon, isometric, and those. And there's some swizzle stuff you can mess with in terms of how these are sort of rotated in the 3D space. Typically, you're just going to leave it as the XYZ, but there can be some swizzle as to how you do this. It's kind of a fun word to say anyway. Cell size, we're just having them be 1 and 1, so it's 1 unit in size for the cell, and there's no gap between them. You could have gaps between the cells, so you could do something like this where you've got a gap between them, and that could make some sort of stylistic. That could be a stylistic choice in your game to have a small gap between them. That maybe when you select a tile, it sort of lights up the area around the tile or something in that gap so that it doesn't overlap with other tiles. And so there are reasons to have a potential gap in there as well. We're just going to leave the gap as all zeros, be the gaps between the tiles. But the grid itself is not what you put the tiles on. You put the tiles on your tile map object. And you can create as many of these as you want. So here I have a tile map. Let's name this one rooms. And then I'm going to create another one. So I go down, 2D object, tile map, and I actually don't need the second grid, so I'm going to move the tile map in there and delete this other grid. Usually it just put it in there together, but it didn't in this case. So let's make sure that it's there. So I have one grid with 2 tile maps. Maybe this tile map is placeables. So I can, my chests and barrels and anything else that I have laying around will be in the placeables tile map. So you can have multiple tile maps that represent different parts of your overall map. So I'm going to show you how to use that right now. So for our rooms, I'm going to select that one. And up here at window, I'm going to go down to 2D, tile palette. And notice we have active tile map. It's certainly set to rooms. So I can change which tile map I'm placing on with the drop down here. Just like I can change my palette from the drop down here. So this one's important. This active tile map is important. Then I'll select my brush. I'll select a tile. And for some reason, and it's done this to me multiple times before. The size on this goes outside of the bounds here. The tiles still look fine when you put them in the tile map. But for some reason in the palette here, there's been a problem. So everything will still sort of look fine in the actual game, but for some reason they like go outside the boundaries when I open up the tile palette again. Now, I have a tile like this, but it's black. So you might think, uh-oh, what's going on? Did I select something wrong? Did I set these up incorrectly? No, everything's okay. The only difference is over here in my rooms tile map, my material needs to be Sprite unlit default. Because we had a lit shader, so we have to make sure we have the correct light on it and from the correct direction and all that. We will use the lit one later, but we don't have to do that at the moment. So to reopen the tile palette, you do a window, 2D tile palette. So now we can start painting stuff. Right? So I can be on the brush tool and I can click right here and I can place this guy. Click on this one and place this guy. And I can place some floor in here like this. And then I can place some of the walls in here. And this one. I have a room. So there's my tiles. And if I want to change the active tile map, because let's say I want to put like a chest in here. If I'm still on the room's tile map, notice that it gets rid of the floor. Zoom in here. The floor is not underneath this anymore. So let's delete that tile. There's an eraser thing here. So I can delete the tile and I can put that, I can paint that floor back in. And then I need to change my active tile map to my placeables tile map. And now I can throw in a barrel. Let's put the barrel here and chest here, and I'll delete the other one. Now notice these are black, again, because I'm on a different tile set now. So I need to go and change a different tile map. So I need to go and change my sprite to unlit default. My shader to unlit default. So now if I hide my placeables, it's just those placeables that are gone. And if I hide my rooms, the placeables are still there. So you can imagine sort of doing this sort of thing with your objects, having a bunch of different sort of layers of your tile map to put different things on that might sort of do different stuff. So I'm going to save that, run. And we have our little circle that moves around, but where do the placeables go? They're not there anymore. Obviously, we don't have any collision. We don't have any of that yet, so we will add that in just a moment. But my placeables are gone. This is one of those situations where we want to look at, for example, the 3D version. Notice how our player sticks a little bit further out. The player's right there, sticks further out, closer to the camera, than my tile map does. So depending on where you want stuff positioned and how you want things to occlude other things, I'm going to close my tile palette here. You can take the placeables, for instance, and we can move it forward or backward. And it doesn't change where anything else is. So I can move it like this. So now that should be visible when I play the game. So you can do that sort of layering thing where you have some of them at different positions. There's also you can also set up using the sorting layers. So if you want to set up some sorting layers so that you just change the order in layer, or you have a sorting layer for placeables and a sorting layer for walls and one for rooms and one for sort of other stuff that maybe the player would go behind, like a bridge or something, then that's something that you can mess around with sorting layers as well. But a very easy way is just change the position towards the camera. So in sort of a 3D look, we can see that the actual rooms are behind the placeables, or in front of the placeables, closer to the camera, and the player is closest in this case. So that's a very common way to deal with that. But when it comes to collisions, we want to make sure we don't leave the walls. And I want to point out something else as well. Let me sort of zoom in here. Notice these lines. You may not see this on yours, but if you just do a regular tile map with a regular camera and you see these lines, and even if we're playing, sometimes they sort of blink in and out. Sometimes they're there, sometimes they're not. It depends on where the camera's located. This is very annoying, and this is not what you want for your tile-based game. No matter what kind of tile-based game you have, you do not want these lines in there. So that's what the Pixel Perfect camera deals with. So I'll show you that in a little bit later as well. Let's move the player. I'll go back to the 2D mode. Let's move our player. So I'm going to click on player, and then up in the top left, we have our sort of options here, and I'm going to grab player and move them in here like this. And I need to adjust the collider here because it's way too big. I'm going to move the player so they're like in the room, because we're going to put some colliders on the walls and stuff. And let's adjust this collider as well. Let's take the radius down to something more reasonable, like that. Just make sure it almost matches our graphic. To make a collider, we're going to mess with our tile map a little bit. So I have placeables and I have rooms, but this is not ideal for a collider setup. So I'm going to make a new tile map, and I'm going to name this one collision. And for the rooms, I'm going to rename this to floor. And we can keep placeables in there. For collision purposes, I'm actually just going to get rid of it. So we'll have floor and collision. But you could have placeables and add a collider to your placeables as well. I'm going to put everything that the player can collide with in the collision. So I'm going to make it so they can't move through the barrel or the chest. So I'm just going to get rid of my placeables one, so we don't have them in there anymore. Now, the floor tile map, or the floor tile grid, still has the walls in it, but the walls should be collision instead. So what I'm going to do is this. I'm going to go Window, 2D, Tile Palette. I'm going to make sure we're on the floor tile map, and I'm going to erase everything but the floor. So I did the eraser tool and just erased it, so it's only the floor here. Then, for my active tile map, I'm going to go to collision, and I'm going to place my walls. And I need to change the shader that it's using as well, so we can actually see it. So I paint my walls in. I'm going to put the barrel and the chest in here as well. So these are all the things that I want to have collision, because we're just about to add that. And for the collision here, I want to have this be the unlit default so we can actually see it. And then I need to move the Z of this just a little bit to the negative so that we can see the stuff that's on top as well. So it looks the same as previously, but now we have all of the collision stuff and we have the floor. So you will oftentimes break up your tile map in this way, where you have multiple active tile maps, where some of them have the collision things, some of them have other stuff on them, some of that basically things that you can walk through and things that you intend to have collision. We're not really going to be doing any more painting, so I'm going to close the tile palette window. And I'm going to add another component to this collision map. So I'm on the collision map right now. I'm going to add a, you want a Tilemap Collider 2D. So Tilemap Collider 2D, I don't really need to change anything here. This should already be set up the way we want it. And if you look closely, you'll notice the outlines here around my chest and my barrel, and then the sort of individual outlines around all the tiles. So each tile now that is in this tile map has a collider. So if I play the game, now I can't move past the wall. But, and let me zoom in here a little bit as well. But there is some weirdness that can happen, and I'm not really seeing a whole lot of it. Notice when I'm moving, like, so I'm trying to move down and then to the left and right. And sometimes you notice this little dip. My little circle does a little dip every once in a while in between what looks like in between the tiles. So I don't know how choppy it is here for you to watch it, but there are dips every once in a while. It sort of does this little like dip thing, this real quick dip, and then gets kicked back out. So it's almost like it's trying to get in between the tiles, because each tile has its own collider. And so there's probably, you know, numerically, there's a little gap between them. And so sometimes I hit that gap and the physics engine tries to jam my circle right in between that gap. It can't, and then it gets pushed back out. So you get this little dip. That's not ideal to have that. You could probably get away with it, depending on what the game is, but it's certainly not an ideal thing to see. Notice I can't move over the chest, and I can't move over the barrel. So again, all this was simply because I added the tiles to a different tile map, and then that tile map I added the Tilemap Collider 2D. To resolve this issue with a lot of tiles, like walls, or imagine like you know, in a platformer, you've got a bunch of sort of platforms and stuff that you're jumping on. You don't want individual colliders for every single tile. So what we do is we add a composite collider 2D. This will automatically add a rigid body because it needs a rigid body. We can set this rigid body to static. It's not going to move. If a rigid body is static, then it is simulated, but it doesn't move. So we can set our rigid body to static. And then in our Tilemap Collider 2D, we say use by composite. And immediately, take a look at what happened here. As soon as I said use by composite, all of the individual tile colliders merged into one collider. There's now a collider. You can see it's sort of have the go around my thing here. My chest is still separate, but the rest of the thing here is all one collider. And you can actually adjust some of these values. So you can have like offset distance. So here, sort of set the offset distance here. So now the chest is now part of fully part of the collider, and there's no gap here with the barrel either. So this composite collider means that you no longer have little gaps, you know, little numerical gaps between the actual tiles. So if we run now, we're not gonna get that little sort of jump thing that tends to happen between the tiles, little trying to fit in between them, and it doesn't work. So that's how I can keep this guy trapped in here. And Nick, remember for the tile palette, so window, 2D, tile palette. So in the rigid body, no, I don't know. I think I looked at one of your previous messages there, Nick. For the rigid body, it's body type. So the rigid body 2D, the one that it created for you. So if you add a composite collider 2D, it will add a rigid body automatically. It's body type. The options are dynamic, which is usually what you want, things that can move. There's kinematic, which are things that can move but don't interact with a bunch of other stuff, or static, which is just they're simulated so other things can interact with them, but they don't move at all. Which is typically what you want for things like walls, or if you're making a platformer, you'd want to make this rigid body that represents the composite collider. You definitely want to make that static so that it can interact with things, but it itself never moves at all. If you do leave something on like dynamic, you can actually put constraints on it. It is more computationally expensive to do this, like behind the scenes. But if you freeze the position and the rotation, then it effectively will do the same thing, because you've effectively made it static. But it's better to just change it to static. So that's the sort of basics of how you can get a collider to work with whatever tiles you want. Yeah, that's and I don't know why, Nathan. I don't know why it was giving me a problem, because that was the way. Maybe I had the velocity V capitalized or something. I don't know why it was giving me a problem with that, because it should be accessible. Just like RB.position is accessible, RB.velocity should be accessible as well, and you should just be able to change it like that. So I don't know why. I don't know if it was something was glitchy. I mean, definitely my VS Code was being a little bit of a pain. So I don't know if there's something related to that was causing the problem. Because I thought that would work. And so same with add velocity. I don't know what the problem was with that either. Maybe I need to clean out my my project solution here and regenerate it. Move here. Make sure save it. There we go. Okay. So we still have this weird thing with these lines. Yeah, see that, but it is very possible with getting some of this that like something like add velocity might be depreciated, because this stuff goes through so many changes that I have to make sure every semester I make sure all of this stuff still works, especially if I update versions. All right, so we have these lines, and this is caused by the camera and the fact that we're doing this sort of pixel perfect thing where we want the pixels to exactly line up. Because of the aspect ratio of the camera, you might not get pixels aligning perfectly if you put two sprites together. Like we're doing here. We have two sprites, they're each 16 pixels apiece. Because of the aspect ratio and because of where the camera is positioned, you can actually get sort of partial pixels that sort of show up, because this is 16 pixels, but it's really not. I'm on a 1440 monitor. So this is actually much more than just 16 pixels. The image itself is 16 pixels, but my monitor is much higher resolution than that. So that's why you get these lines in there, because it's not a full sort of pixel in the image, but I still need to render it on my correct aspect ratio, correct resolution monitor. So that's what this pixel perfect camera deals with. So you add this just by adding a component to the main camera, the one that has the Cinemachine brain. And there's a few settings to do in here. As soon as I enable it here, it should back here. Might have to play it here. It should deal with the lines the way it's currently set up. But there's so right now you can see that there's no more lines here. But one of the things you'll notice when the camera moves, it sort of moves in a choppy way. So if you pay a close attention when the pixel perfect camera's on and the camera's sort of slowing down, getting to where it has the player in the view, if you watch carefully, you'll sort of see it moves in a little bit choppily, and that's because it is only moving such that all of the aspect ratio and resolution is all divisible correctly, so that we don't get these lines. So it's going to move in a more choppy way, which is sort of expected with sort of a pixely type game. So the things that you have to look for here are asset pixels per unit. So right now it's 16, right? Because my asset is 16 pixels per unit. That's the way I set up my original sprites. That's something to remember. And then there's the reference resolution. What resolution do you want this to be based on? Do you want your camera to be based on? So for example, so I'm going to go back to this, to this sort of standard view here. If I said something like 16 by 16, like this, I went in here, I'm just going to get the equivalent of 16 pixels by 16 pixels in my game. It's not going to look very good, of course, but I'm going to get that equivalent for what the camera shows. If I make this larger, so you want to make sure that all this is divisible by the pixels per unit. So pixels per unit is 16. So if I picked 160 by 160, then I'm going to get a square region that is 160 by 160. If I sort of halve this, so like 80, and you can change this while it runs, although it can kind of screw stuff up here like this. If I changed it to be 80 by 80 for the reference resolution, then it's still going to be square. I changed it in here. It's still going to be square, but it should be more sort of zoomed in, or should look more zoomed in. So the reference resolution is essentially make it the way you want it, but make sure that the values in here are divisible by your pixels per unit. That way you're not going to have to worry about any of these other squares. And typically you say crop frame X and Y. If you don't have this on, then it's not going to crop it for you to be the appropriate aspect ratio of whatever you want. So in that case, you can still get some weirdness, and there's an error that sort of came out of this as well because I did it while it was running. So you definitely want to do the crop frame. So whatever aspect ratio you want, in this case it's square, which is probably not what you want, is what you can sort of set this to. So you do have to mess a little bit with resolution stuff. The one that I had before was 160 by 96. So that gave me a decent sort of aspect ratio like this, and keeps me without all of the lines in there. So it does take a little bit of messing around with for the pixel perfect camera, but once you sort of get used to what this stuff means, so the pixels per unit and the reference resolution, then it's easy to just mess around with to get it to look the way that you want it to look. So I'd keep that in mind. If you want a pixel sort of look, especially when it comes to a tile map in your game, make sure that you use the pixel perfect camera attached to whatever camera has the Cinemachine brain on it. And then you should be ready to go. Obviously, you need more code if you wanted to just have the character move on the tiles. You have to move them the appropriate distance rather than just having a free move like this, but this is the idea here. All right, so and the rest of the slides are basically just sort of showing that. If you do notice your images are going into the tiles, but they're too small or they're too big, then you need to go back to the sprite itself and add in and make sure that you have the pixels per unit correct. So we had 16 pixels per unit so that we could fill up the entire sort of square. So that's something you might have to mess with as well. And then the collision, we made sure to add a Tilemap Collider, and then later we add the composite collider and make sure that we can sort of mess around with the rigid body and stuff. We don't want gravity on the rigid body, or we can set the body type to static, like I said. And then we got rid of the lines around here with the pixel perfect camera. It was experimental for URP. Again, there looked like there was a non-experimental version, so you could try that one out as well and make sure that it works properly for you. But when I originally made this lecture, it was the only one available was experimental for the URP. And that's basically it. That's the basics of the tile map. Now, there's much nicer tools as well for tile maps. There's a rule tile, which means I can paint with one tile. This can be a real pain if you've got dozens of tiles. You got dozens of tiles, and you're like, all right, pick this one, paint it. Pick this one, paint it. Pick this one, paint it. That's a real pain. So there's a rule tile that exists that allows you to pick the rule tile. It would just be one of the tiles in here. It lets you pick the rule tile, and then you could just paint. And depending on what tiles are next to the tile that you paint, it will display a specific tile. So that's something that we'll mess around with a little bit. There's also a prefab brush, so you can literally brush in prefabs rather than just tiles, which is cool. There's some simple lighting that's easy to accomplish as well. We used unlit materials here, but obviously if you want some sort of mood lighting in your Tilemap game, you probably want to have actual lighting. So there's some simple 2D lighting as well. And I want to do a quick overview, kind of like today with the little Spectre fix update thing. I want to do a quick overview of a raycast. These are important, particularly in 3D games, but in 2D games, it can be important as well. So I do a quick overview of that just to give you sort of one last piece. Obviously, I wish the class had I wish the class was longer because there's lots of stuff to cover, but some of these things are things that you can also look up yourself as well. So that's about it. We're just about out of time. So I will see you guys next Tuesday for our last class. Let me grab one more thing here. The final project, the stuff for this is on Blackboard. There is a link to the repository for this. It's blank. There's nothing in the repository, so you'll have to load stuff in there. There's 3 deliverables. There's a GDD. So I want you to look at I want you to create a simple GDD. It doesn't have to be as thorough as the previous ones. I just want to make sure that every team member is on the same page. You're going to give me the Unity project, and you will be doing a presentation during our normal finals time. So I have a little bit of information about all of that in here. Graphics-wise, you can use the Kenny NL graphics if you want to. I'd recommend trying to make your own sounds. But graphics-wise, if you want to use one of the Tilemaps from him, he's got lots of them, or some of the 3D assets from him as well, feel free to do that too. So definitely read through this. The link to the GitHub Classroom is on the Blackboard one as well. So make sure that you sort of grab that project, which really just means basically pushing your code up to it. Andy, the regular finals time for this class is on the 10th. And I think I don't remember the time. It's like 3 to 5 or something, but it is on the 10th. I'll make sure to send out an email next week to let people know what's going on. But you want to work on this over the weekend, essentially 4th to 7th. So basically you have the entire time. As soon as it's the 8th, I'd like you to have your stuff pushed up. And if you didn't get everything finished, if you didn't get all of the features you want finished, that's the way these sort of game jams tend to go. So write a GDD so everybody's on the same page. Try to make sure that you can get the sort of main features done, and if there's extra stuff you want to add in, great. The presentation will basically be sort of demo type stuff. So inspiration for your game, any interesting features or cool shaders you made, and a demo. So imagine it being 10 to 15 minutes for the presentation. But a bunch of that stuff is in here. If you have questions over the weekend, definitely let me know, particularly about the sort of final project presentation stuff as well. Definitely feel free to ask, and I can make sure to clarify things. Theme is you can't save them all, so take that as you will, and think about a game you can make related to that. All right, so that is now all. Have a good weekend making games, and I will see you guys next week.
Oh, Professor?
Yep.
I was wondering if I could get some. I've been having issues with the previous game. Mm-hmm. I'm not sure what the issue is. One second. So I'll open it. Can I share my screen?
Yes.
Okay, cool.